Okay, so in this problem, we're going to see another way to apply solving quadratic equations. So let's do a little bit of review of what we should have gotten out of a geometry class in our past. So when we have a right triangle, remember a right triangle just means one of the angles here makes a 90-degree angle here. And when we have a right triangle, the longest side here is always opposite of the largest angle, so the 90-degree angle. And we call this side right here, it's called the hypotenuse. And that's just a fancy word to describe the longest side of the triangle. It's the side that is opposite of the 90-degree angle, and it's always the longest side. Now, the other two sides of the triangle that connect to make this 90-degree angle, these are called the legs of the triangle. They are the sides adjacent. Adjacent just means right next to the right triangle. So they are the shortest sides. So when you know two of the sides of a right triangle and you want to find the third without having to measure it, we can use what's called the Pythagorean theorem. So the Pythagorean theorem only works for a right triangle, and the formula is a squared plus b squared equals c squared. So we have to plug in the sides of the triangle into this formula. So the c is going to be the longest side, and then the a and the b, it doesn't matter which one is which, is going to go here in the formula. So let's take a look at our application problem number 13. It says a 13-foot ladder leans against the side of a house. So I'm going to draw a picture. Here's my house. Okay, so there's my house. And there's a ladder that's leaning against the house. Okay, and it says that the ladder is 13 feet long. And it says if the distance from the bottom of the ladder, so right here, the bottom of the ladder of the house is 5 feet, it wants to know how high up on the house the ladder goes. So the reason why this is a right triangle type of a picture here, so if I break it apart right here, we have the ladder's 13, the height away is 5, and we want to find how high up it reaches. So the reason why we know this is a right triangle is because when you build a house, you don't build the house slanted. It's straight up on the ground. So that's how we know, given this information, how we should get a right triangle out of that information there. So then we would know when we have two sides and we're missing one, that's when we can use a squared plus b squared equals c squared. And when we substitute in for c, it's always the side that is opposite of the right angle. So that's why I'm going to put 13 here. And then it doesn't matter which one's which, so I'm going to have this be a and this be b. So a is 5 and b, we don't know. So to solve this equation, it has the highest exponent of 2, right? So that's why it's in this chapter. I'm going to go ahead and simplify. So 5 squared is 25. And then 13 squared is 169. So at this point of the problem, there's actually two ways to continue this problem. So I'm going to show you both ways because the second way you may have seen it in a previous math class. However, the second way I'm going to show you, we are going to discuss that further in chapter 8 in this class because it uses radicals, which that's our focus in chapter 8. So right now in this current chapter, our focus is on solving equations with exponents using factoring. So to factor, we learned it has to equal 0. So that's why I'm going to do minus 169 on both sides. And then I'm going to put the b squared first. And then 25 minus 169 is negative 144. And then once the equation equals 0, we can solve this by factoring. And this is a difference of squares because b times b is b squared and 12 times 12 is 144. So we can rewrite this as b minus 12 times b plus 12. And then once our equation is in factored form, we let each factor equal 0 and solve the equation. So we would get b minus 12 equals 0 and b plus 12 equals 0. And we would get b equals 12 as a solution. And we would get b equals negative 12. Now, since b was our own unknown side in this problem, we know that we can't have a negative side length, so that is extraneous. And so we get that our answer is 12. So the question asked, how high up the house does the ladder reach? So we would say the ladder reaches 12 feet on the house. So it reaches a height of 12 feet. Now, the other way we could solve this problem as well is if we go back to right here, instead of setting it equal to 0, so if we go back to this part right here, the other way we could do it is to get the variable by itself. So we would subtract 25 to both sides. And we would get b squared equals 144. And then what we're going to learn again in chapter 8 is to get rid of an exponent that is a 2. We could square root both sides. And we're going to talk about more in detail why this works. I mean, at this point, you could understand here that 12 to the second power is 144 and negative 12 to the second power is 144. So these would essentially undo each other, and we would get b equals plus or minus 12, but we already discussed why we can't have the negative answer. So we would get that the unknown side is 12 feet. So when you're using the Pythagorean theorem, just a reminder from your geometry class again, you always have to have C be the longest side, and the longest side is called the hypotenuse. It is always diagonal from that 90-degree angle, and A and B does not matter. You can pick whichever one you want to have be the A variable and the B variable.